Hello students, in the last class I gave you two questions. I hope you tried these two questions. So let's discuss the answers for these two questions, okay? So this was the first question in which you have to find the domain of the function, okay? So let's take fx is equals to under root 2 minus x minus 1 upon under root 9 minus x square. You know the procedure. This is one of your function. Let's consider this as f1x and let's consider this as f2x. Find the domain of f1x, find the domain of f2x, and take intersection of both the domains, okay? So if I'm taking f1x, which is under root 2 minus x, you know that for the under root we know one rule, that whatever is inside the under root, that needs to be greater than equal to 0. That means you know that x is having negative sign, so you have to make it positive. If you want to make it positive, then inequality sign will be reversed. So x minus 2 will be less than equals to 0, x will be less than or equal to 2. This is your one of the domain you got, which is x belong to minus infinite to 2 including. Clear? Now let's talk about f2x. Your f2x function is 1 upon under root 9 minus x square. You know that under root is in the denominator, that means 9 minus x square has to be greater than equals to 0. This is the rule for any kind of function which is inside the under root, but you have to understand that greater than equals to is not possible. Why not possible? Because when this under root will be 0, it will be giving you 1 upon 0, which is approaching to infinite. So this is not possible. So you remember one more rule, that whenever 1 upon something under root is there, then that whole quantity should be greater than 0, not greater than equal to 0. Again, x square is having negative value, so you have to make it positive. How to make it positive? By multiplying with the negative sign. That means x square minus 9 will be less than 0, inequality sign will be reversed. Now factorize it. X minus 3 into x plus 3 should be less than 0. Draw the number line. You know two critical points are there, minus 3 and 3. Assign the sign, positive, negative, positive. You want less than 0, that means you want where the negative sign is here. This will be your solution. So you got the domain for f2x is minus 3 to 3. Now you have to take intersection of both. You want to take intersection of both. So what I told you, you just draw everything on the same number line. So this is the critical point. Minus 3 is also critical point. 3 is also critical point. So one of the solution is minus 3 to 3 for f2x, and one is from 2 to minus infinite to 2. Okay, so where you are seeing the two lines, here you are seeing, right? So the domain of fx will be from minus 3 to 2 including, because minus 3 is not included. You can see that I have put open circle here because you got this as a solution. Okay, I hope you understand. Let's go back to the second question. The second question was fx is equals to under root 3 minus 2x minus x square. Let me see once again. Yes, okay. Now you know 3, whatever is inside the under root, that has to be greater than equals to 0. But x square is having negative sign, so multiply with the negative. X square plus 2x minus 3 should be less than equal to 0. After factorizing, you will be getting x minus 3, x plus 3 into x minus 1 will be less than equal to 0. Draw the number line, mark the critical points. Minus 3 and 1 are the critical points, plus minus plus. You want negative solution, that means this will be your solution. So what is the domain of fx? The domain of fx is minus 3 to 1. I hope these two questions are clear to you. There should not be any doubt. If there is any doubt, you can just write down in the comment section. Now let's discuss one more question of finding the domain. Question is, find the domain of fx is equal to under root 4 minus under root x square minus 9. Okay. After seeing the question, do not get afraid. You just remember the rules that I told you. Whatever is inside the under root, that has to be greater than equal to 0. That means, see, First, if you are seeing x square minus 9 is also inside the under root, that means x square minus 9 has to be greater than equals to 0. This is your first rule. And second is, there are two under roots, right? This is your second under root, that means inside the second under root, whatever is the quantity, which is 4 minus under root x square minus 9, has to be greater than equal to 0. Now solve both two inequalities and try to find the domain for both, and then take the intersection. That will be your final answer. Okay, so let's do this. For this, x minus 3 into x plus 3 should be greater than equals to 0. Draw the number line. Minus 3 plus 3 plus minus plus, you should know that greater than equals to 0 means you want positive solution, so this will be your solution. And for this, what you can do is 4 should be greater than equals to under root x square minus 9. I hope this is clear. I just shifted this here. Okay, you can do this in inequality. Okay, now you remember one rule. What is the rule? Whenever there is inequality sign, let's say a is greater than b is given, okay, and if a is positive and b is also positive, then you can square on both the sides and inequality sign will not change. That means a square will be greater than b square. Understood? Now see here, 4 is positive, okay, and under root x square minus 9 is also giving you positive value. Why? Because under root cannot give you negative value, right? So whenever you are squaring this, inequality sign will not change. That means 16 will be greater than equals to x square minus 9. You can do this. Okay, now I'm just shifting this 16 to here, so x square minus 25 will be less than equals to 0. Now factorize it. X minus 5 into x plus 5 should be less than equals to 0. So again draw the number line. Minus 5, 5 plus minus plus, you want a negative, has to be solution, so this is your solution. Just take intersection of both because you have put and sign here. Draw the number line. Mark all the points that you are getting. One of the solution is from minus 5 to 5 and other solution is from minus infinite to minus 3 and 3 to infinite. Okay, so where you are getting the common solution, where you are seeing the two lines, right? So this will be your final solution. Take some time and understand what I told you. So the domain of fx is equal to minus 5 to minus 3 union 3 to 5. This is clear. There should be no doubt. Two functions were there inside the under root, so I just put both the conditions and put and sign. You have to take intersection. I solved simply. One more rule you have to remember, that if a is greater than b and a and b both are positive, then a square will also be greater than b square. Okay, so I just applied this rule because 4 is also positive and under root x square minus 9 is also positive, so you can square it and you can solve it. After solving, you got two solutions. You just took intersection of both and then this is your final solution. Okay, now I'm giving you one more question, one more illustration for you. Okay, so let's take one more. Wait, again you have to find the domain of the function. Fx is equal to under root 9 minus x square upon x square minus 4. I want you to solve this. The answer for this is minus 3 to 2 union 2 to 3. I want you to solve this question. Okay, and one more. Fx is equals to x minus 3 upon x plus 3 under root x square minus 4. See, if you are seeing this, fx is having three kind of function. One is f1x, then f2x, and then f3x, right? If I'll ask you what is the domain for f1x, you know that f1x is a kind of polynomial function. This is your f1x, so the domain for this will be r. Again, domain for f2x will be r because it is also a polynomial function. If I'll ask you what is the domain for f3x, your answer will be x square minus 4 has to be greater than equals to 0. That means x minus 2 into x plus 2 should be greater than equals to 0. So what is the solution you got? You got from here to here and from here to here after assigning the sign. Okay, you got the domain for all three. Okay, what is the rule when something in the numerator and something in the denominator? Your final domain will be domain of f1x intersection domain of f2x intersection domain of f3x minus the point at which f2x is giving you 0 value and f3x is giving you 0 value. Correct? Okay, now if I'll ask you what is the intersection of all these three domains? See, r intersection r is r, but r intersection this will be this whole portion. That means the domain of f will be from minus infinite to minus 2 union 2 to infinite. You are taking the common part. R means I am talking about the whole part, and if this is your this is the smallest part from the r, so when you are taking intersection this will be the final part. Okay, now you have to subtract the points at which this is these two functions are giving you 0 value. So let's talk about f2x. Where f2x is giving you 0 value at x is equals to minus 3, so you have to exclude minus 3 here. Okay, and if I talk about the other function which is x square minus 4, on which points it is giving you 0 value, then your answer will be minus 2 and 2. Correct? So this will be your final domain. Okay, either you write like this or you write like this. Both are correct. What I did is, instead of writing minus 2 and 2, I just excluded here itself. So I just use open bracket. Clear? So don't get afraid by seeing the question that lots of functions are there or lots of expression are there, how to solve these kind of questions. See, it is very easy. You just go step by step and you will be able to understand. Fine. Thank you. In the next part, we will understand about the range of a function and how to find the range of the functions. Again, for the domain part, some special kind of functions are remaining. That means logarithm kind of functions. When you are drawing the graph of the function, how to draw, that we'll discuss in the other parts. But for now, if some basic functions are given, you need to understand that how to find the domain of the function. Okay. Thank you.